both flight dynamics engineers in GMB, and we are part of the team of Focusoc Conjunction Assessment Service. So I'd like to say that it's a real pleasure to have all of you here today. So in today's webinar, we will speak about the problem of space debris, and probably you can anticipate that with this image from ESA. And we'll also speak about the actual situation in space and how we can act so that the problem does not get bigger. We will speak about our solution and its role in the problem, and how we think it could be helpful to enhance satellite operations so that they are safer, trying to minimize collision risks. Besides, at the end, as Tatiana mentioned, we will have some time for questions and discussion. We will split the webinar in 3 main blocks. The first one will speak about the so-called space era, the new space era, the current situation in space, and the space debris problem in general. And after that, we will speak about how to prevent this problem by means of the conjunction detection process, its advantages and difficulties. And finally, we will introduce our system. We will try to explain how this works and why it is helpful inside the whole problem. And now my colleague Andrés will start with the first section, the new space era.
Thank you, Miguel. So starting from the beginning, what is the new space era? Traditionally, the ecosystem of space was controlled by national activity and was a state-only playground. In the past several years, we have witnessed dramatic changes in global space activity toward greater involvement by the private sector. These changes come together under the overarching expression new space. Nowadays, there are private launchers, private constructors of satellites, private operators, and so on. With the increment of space company, the number of spacecraft has also increased. However, it was from a few years ago when the situation dramatically changed, with the announcement of the so-called mega constellations. Before OneWeb or SpaceX, the biggest constellation were perhaps GNSS constellations of around 30 satellites, and maybe communications in LEO, such as Iridium, with around 60 satellites. There were few projects of constellation, and all of them had only a few dozen of satellites. However, both these new projects contain several hundred of satellites in LEO. In fact, we have obtained this plot with data from SpaceTrack, and it can be seen how the number of objects in different heights have been increasing over the last 6 months. The trend is clear. While in GEO or MEO just a dozen new objects were launched, a total of 1,393 were put in LEO orbit. That means a growth of around 6 satellites per day. Starlink satellites represents around the 60% of these new objects, and OneWeb another 10%. But even if those mega projects do not exist, the growth of new satellites in LEO will be extremely different from the one of GEO or MEO orbits. It is true, of course, that GEO belt is already crowded, but as you can see, there is a great interest of commercial projects in LEO. So in the coming years, the population of LEO may double the current. And spacecraft are not the only thing flying above our heads. We all have heard about the space debris. And in fact, in the catalogue of the 18th Space Squadron, there are more than 20,000 objects. Those objects are categorized in 3 main groups: debris, rocket body, and payload. And as you can see, only a 30% of the total amount of objects are payloads. The rest are just debris or leftovers from past missions. Nevertheless, the problem is even bigger because not all spacecraft are active. In fact, an 80% of objects are non-active objects. That leads to a situation in which a 20% of the population should dodge the other 80%. One interesting example that why this is happening is the example of the Vanguard 1, the 4th satellite put in orbit by humankind. And the thing is that this object is still up there. And from 1958 to the present day, many spacecraft have been abandoned and shut down in stable orbits. Eventually, this habit of abandoning a satellite in a stable orbit without any possibility of control lead to catastrophic consequences, such as the collision between the Iridium-33 and the Cosmos 2251 in 2009. In this case, the Cosmos satellite was an inactive satellite, and the accident caused the complete destruction of both of them. And of course, a huge amount of debris was created that day. Nowadays, there is still no international rule or treaty about the space debris mitigation. However, the 25-year rule is widely extended. So new satellites in LEO orbit would eventually fall into the atmosphere in a 25-year gap. Nevertheless, if the growth of satellites continue to be the same, this 25-year period may be too long to reach a stable status in the number of satellites in orbit. And we have talked only about the objects categorized as payload. That, just to remember, represent only about 30% of all the objects present in the catalog. The other 70% are debris. These objects has a huge variety of sizes and shapes, but luckily most of them are quite small. In fact, in the space track catalog, there are only objects with a size of more than 10 centimeters because of the difficulty to track them correctly or even detect them from Earth. There are much more objects, and even when they can seem small, the high relative speed between a satellite and those objects can have disastrous consequences. This is an example of an impact in the robotic arm of the International Space Station last May, and as it can be seen, even a small object can cause a great amount of damage. The speed at which these encounters take place is many times faster than a bullet. An impact at a critical point would cause the mission to fail. And in this case, it does not hit anyone, but imagine that an astronaut was working there.
Yeah, in fact, it's easy to find more examples like that. So it's not an isolated case. For instance, in this photo, this is one of the solar panels of Sentinel-1 satellites, and it was hit by a very small object, but it generated a hole of more than 40 centimeters diameter, which can be easily appreciated. And it was rapidly identified by the operators because of a sudden drop in the power supply of the panel, and also because there were changes in altitude and orbit satellites and the satellite orbit. So it is thought that maybe the impact was caused by a paint drop or something very small. So try to imagine the consequences of an impact with a bigger object. Of course, the satellite could be completely destroyed, but even if it's not, keep in mind that an impact could be fatal too, because the power supply or any other key system could be completely lost. And also the orbit or the altitude could be massively modified with a very negative impact on the mission.
Yeah, and talking again about the ISS, the cupola module was hit by a small fragment of debris, no greater of a few thousands of millimeters. And the impact caused a 7-millimeter diameter circular chip. In this case, the space station is prepared to survive these small hits, of course. And all critical structure or areas, as this glass, are well shielded. However, anything about 1 centimeter would penetrate the shields of the station's crew module, depressurizing the station and with clear catastrophic consequences.
Yeah, totally. Another interesting example involves the Hubble telescope, which has been more than 30 years orbiting around Earth up to now. So as you can see in the images, solar panels have been hit more than once by some particles. So actually in 1993, there was a mission to substitute them. One of the old panels was brought back to Earth to be studied, and the other one was launched into space in such a way that it re-entered in the atmosphere. Actually, in the right image, we can see an astronaut launching one of the panels into space. Then 9 years later, there was another mission to substitute the panels. So in the end, that proves that low Earth orbits are a very hostile environment.
Also, usually the origin of the debris is accidental, caused by a collision, an explosion, or of a spacecraft or a launcher, or wherever. But there are other debris that are intentionally caused. One curious example is the one of the Westford needles. In the 60s, there was a project to create an artificial ionosphere to improve Earth communication. And to do so, the plan was to put in orbit millions of small needles of copper of around 2 centimeters length in a belt around the Earth. And even in that moment, they do not come with international agreement about it. But after a first attempt in 1961 that fails, they finally managed to establish communication with the created belt on 1963. With the development of modern spacecraft, this technology was abandoned, with the theory that the needles would eventually fall after 3 or 5 years due to the sun radiation pressure. But that didn't happen. And in the present days, some of them are still flying over us. The initial idea was to put 480 million needles in orbit. So you can see the lack of concern about the space debris when this project was designed. Nowadays, some of these needles have been grouped so they can be tracked, avoiding possible collisions with them. And actually, a total of 45 groups of needles are present in a space track catalog, still flying in orbits above 3,000 kilometers.
So as we've seen, there was not a big concern about space debris years ago, but fortunately nowadays things are different. There exists an awareness about the space debris accumulation, and the actual missions are planned so that the satellites re-enter the atmosphere at the end of the mission, or so that they are sent to a graveyard orbit, which usually happens in GEO satellites because they are far away from the atmosphere. But despite these initiatives, there's still a problem. In fact, even if humanity stopped launching objects into orbit, the number of objects orbiting Earth may even continue to grow in the long term because of the so-called Kessler syndrome, or more simply the collisional cascade. So if a spacecraft by any reason is destroyed, or if there is a collision between two objects, it creates a cloud of debris that could collide with other objects, creating more clouds of debris, colliding with more objects, and so on. And this is kind of a snowball effect that could be triggered if there was a collision. For instance, the effect in low Earth orbit, which is very, very populated, could be catastrophic due to the high density of objects. Sometimes it's said that the LEO region could become completely unusable. And this effect could also happen in GEO because there are not so many objects in there, but this orbit is very, very densely populated. So yeah, something similar could happen there too. So in order to try and mitigate this problem, there are some initiatives and ideas about active space debris removal. So in the image, we can see a simulation of how the low Earth orbit could be if the business remains as usual. So it's pretty dense from my point of view. And it doesn't seem like people is going to stop launching objects into space. So maybe in some time, there will be a new business in space consisting on removing space debris actively. For instance, there have been some successful tests about capturing debris using nets, which from my point of view is a very slow method because you have to launch satellites to catch other satellites, but it's really difficult to think of a quick method to clean space debris. It's a really challenging problem. Other ideas include magnetic feathers that use electrical current to deorbit satellites at the end of its life, avoiding the use of a final maneuver that would need more propellant. And as you can see here, there are other methods such as drag sails or even harpoons. We even heard about ejecting water in an orbit that you want to clean, trying to generate kind of an artificial atmosphere, generating drag and making objects re-enter. So I don't know if this would work, but now we are kind of in a brainstorming phase. So let's see how this evolves, and we really hope that some of those ideas succeed and that it becomes possible to actually clean space. Sometimes this space debris problem is compared with a disease. So we have spoken about this active debris removal, which could be interpreted as curing that disease. But actually, we can also try and prevent it. So even though this disease has already started, we can and we should try to prevent the disease to keep expanding. And one of the ways to try to do that is the conjunction detection. So basically what we can do is try to anticipate possible collisions and then avoid these risky events. And a situation in which two objects are very close is known as a conjunction. And by means of data processing and orbit propagation, it is possible to anticipate the orbit that a satellite is going to follow, and then predict when a risky encounter is going to happen. This is known as conjunction assessment. And by means of that information, the operators can maneuver to try to mitigate the risk and avoid collisions, which is known as collision avoidance. Basically, you can avoid a hit if you know when and where it's coming from.
Yeah, and to predict all this conjunction, first thing we need is to know where are the objects, where will they be, and how they are, much more information about them. There are several data providers such as EUSST, ExoAnalytics, or Leo Labs, and there are others that also maintain an updated catalog, such as the 18th Space Squadron or JSC Bimpel, just to name a few. And in the case of the catalog of the 18th Space Squadron, they provide a catalog with objects greater than 10 centimeters, and this catalog contains more than 20,000 accurate orbits. The estimation of the number of objects greater than a centimeter is of 100,000 or maybe even 200,000.
Yeah, pretty big number.
And here we have prepared part of this precipitation with a tool from the University of Texas, but we had experienced some problems and we only could extract this image. Yeah. So we will pass you the link in case you want to see it. But the idea was to compare Bimpel and the 18th Space Squadron catalogs. The image we have here has information of both sources. Pink dots are not catalogized objects, and blue are the inactive satellites, and orange are the active ones. But to have a rough idea of which source is which, most of the pink dots are from Bimpel, while the oranges and blue ones are from the 18th Space Squadron. And as you can see, most of the that are present in the 18 catalog are in LEO and GEO regimes, or cemetery orbit in the case of GEO belt. However, the Bimpel catalog contains a lot of objects in MEO regimes and also for high eccentricity orbits. So just to start, it is difficult to reach a complete vision of all the objects in the space following only one provider. However, we use the 18 catalog for our tool for Focusoc, because in LEO and GEO orbits where our clients are working, they have a good sample of the objects flying there. In addition, the objects present in the Bimpel catalog may be quite difficult to track with enough precision because of its size or orbit. And it is not only important to have objects tracked, but also to be sure that the information is correct and reliable. So first thing is that objects smaller than 10 centimeters are quite hard to track. However, a cannonball might not be much bigger than 10 centimeters of diameter. And actually, a 5-centimeter object could mean a critical impact, as we have talked. We are not tracking really dangerous objects with high energy and, of course, high destruction power. There are a lot of initiatives to enhance actual radars to be able to track smaller objects. Some laser radars have provided good results. For instance, EOS laser can achieve better sensitivity of around 6 millimeters in LEO. And another example is Space Fence, used by the 20th Space Squadron that are trying to improve the sensibility and be able to track around 100,000 new objects, having a more realistic view of the situation up there. Data from this radar will provide to the 18th Space Squadron, and probably in the future, their catalog will be growing, including a lot of smaller objects. Actually, NORAD ID will be modified in the future because the actual number of digits won't be enough to catalog all the objects. But fortunately, the density of very dangerous non-traceable objects is not that high. but we are relying on luck here. One thing to keep in mind here is that if we were able to track smaller objects, then we will require a lot more of computational effort to be able to process this amount of data. And this will also be a challenge.
Yeah, pretty much. So speaking about the data, as you could imagine, the conjunction assessment process requires a lot of data on data processing. And in order to get all this data, we need a global network of telescopes, radars, sensors that are able to track all the satellites and that are continuously tracking all the objects in space. So some companies and institutions are dedicated to that, such as Numerica, ISON, or Leo Labs, among others. And this process also includes satellite-to-satellite positioning. For instance, GPS and Galileo are not only used to guide people while driving, but even more importantly, to locate satellites in low Earth orbits. So after obtaining all this data, it has to be processed by means of orbit determination to get actual satellite orbits. And then when facing conjunction assessment, we need to process all those orbits. There are, of course, several ways to express this information. And here we're going to mention just a couple of them so that all of you can get an idea of the formats of the data. One of them, which is widely used, is the true line element, or TLE. So basically, it describes an orbit using a simplified model described by the parameters included in 2 lines of data. So you can get an estimation of the orbit of the satellites in just two lines. Sorry. You can see here an example for various satellites. And of course, one of the advantages is the light processing. But when trying to propagate TLEs for some days, they are not accurate enough. Hence, it's not very recommendable to rely only on TLEs when you are trying to assess conjunctions with some time in advance. Other way of expressing orbits, and that's actually the format we use, is to directly process the satellite ephemeris with respect to time. This is the format used by 18th Space Squadron for their SP catalog, and also by other orbit catalogs such as JSC Vimpel. And this is, of course, more accurate because you avoid the propagation error. But you have to process a lot of data in comparison with TLEs. Here we have an example of just a fragment of a file for just one object. And it isn't complete. The file is much larger. And as you can imagine, computational cost is very high when trying to compute conjunctions among a lot of orbits.
And finally, we have to talk about conjunction. It is not possible to speak about them and not mention CDMs. There are so many conjunctions daily that there is a CCSDS standard to express them. And it is also a way to directly provide information about conjunctions to operators as a reporting method. The standard includes not only information about the conjunction, but also about how it was computed, so the analysis can be repeated. Maybe many operators know about this standard of reporting conjunctions because the 18th Space Squadron use it to report about them. Apart from the service of maintaining an updated catalog, they also inform about any conjunction with high risk, less than 5 kilometers in the case of GeoBelt and 1 kilometer in the case of LEO. But there is one curious fact about the CDMs provided by the 18th Squadron. In some of them, an unknown object appears suddenly, and we cannot compute this conjunction in advance because some military missions are classified, and because of that, these objects are not present in the catalog. We only can know about them when they appear in a CDM. Because of that, the conjunction assessment process can be enhanced if the CDMs are also analyzed together with the catalog.
Yeah, so I've got a comment here. We mentioned before that the CDMs are generated by 18th Space Squadron when the missed distance is less than 5 kilometers. But in this case, we have in the missed distance for the conjunction almost 17 kilometers. So I think it's interesting if we explain this fact.
Yes, that is true. However, this report was produced by Focusoc. And in our case, we have access to operational orbits that we will see how far they may be from the catalog one. So in this case, a CDM with an unknown object will cause maybe a panic status, but thanks to the use of operational orbits, we can detect false alarms.
Yep.
And well, in order to compute conjunctions, first of all, we have to define what we consider a conjunction. And to do that, we need to define a screening volume. Only in the case that an object crosses the volume for a target, we say there were a conjunction. These volumes depend on the orbital regime. And this is because the closer objects are to Earth, the more precise we know its position. So we can use smaller volumes. In this table, we have the general values that are used in Focusoc. It is true that they may seem quite conservative, but as we are using active objects, that is with maneuvers, we prefer to be able to follow the evolution of non-risky encounters that in the long term, and maybe with some maneuvers, could lead to a dangerous scenario. The idea is to know about conjunction the sooner. More time to think, coordinate, and study, and of course, usually less propellant. Another fact to take into account is that the spherical volumes may be not the best option. In fact, in radial direction, the precision of the position used to be higher than in a long or cross track. Because of that, for many operators, we make smaller this screening volume to categorize encounter as high risk. And well, talking about high risk, the next thing to take into consideration is when an event should really concern us. According to the 18 Space Squadron reporting criteria, a high-risk event does not only depend on the mean distance between objects, but also in the time of closest approach. And they also make that differentiation depending on the orbital regime, as you can see. In the case of the 18 Space Squadron, they only generate CDM in the case of dangerous events. So I say 5 kilometers for GEO and 1 kilometer for LEO orbit. And as the mean distance and the TCA diminish, the risk grows, obviously. And because of that, they increase how they report, from only with a CDM to a CDM and an email, and even a phone call for very high-risk encounters, in which a maneuver should be done immediately. There are a huge number of risky events, but the real dangerous ones do not occur so often. In addition, in the case a potential risky event happened involving an active satellite, it will perform an avoidance maneuver. But when both satellites are not manned, we cannot do other thing but to wait. And we can show you a pair of examples of this situation.
Yeah, for instance, we have here an example of a conjunction that occurred at the beginning of 2020. So in this case, two inactive objects were very close to each other. One of them was pretty big. You have the dimensions in here, and the other one was not precisely small. So in that case, we analyzed the conjunction, and our system detected 15 meters of missed distance. And the other organizations that were also monitoring the conjunction estimated equivalent distances, such as 20 or 30 meters. And the probability of collision was bigger than 1–2%, which is actually a very dangerous value when speaking about conjunctions. And there's an even worse case. So in April of this year, there was a very risky conjunction between other two inactive objects. So in this case, we have this graphical representation of the conjunction by USST with the combined size of the objects and also the combined uncertainty. So in this case, the probability of collision was around 20 or 30%, which is incredibly high. But as the two objects were not able to maneuver, it was not possible to act in order to avoid the event. Everybody was just staring at the event with crossed fingers. So this is one of the things that we should try to improve in the future. Maybe if active space debris succeeds, it will be possible to avoid this kind of situations. I don't know, but we have to try to get better at this.
Yeah. And now is the time to speak about what we actually do. We are going to explain some details of the system and how we operate with Focusoc. So first of all, Focusoc is a conjunction assessment service, and we use the 18 Space Squadron high accuracy catalog, and we extend the validity of the data in order to anticipate conjunctions as much as possible. It is a real-time service with two main features: on-demand reporting and routine reports. In any case, to have the best possible accuracy and validity of data, we always try to use the most recent data we can obtain. So the first thing is how we process the catalog. The orbits uploaded by the 18 Space Squadron have 4 days of validity. We are continuously checking if they have uploaded a new version. Normally, they update the data once a day. And when an update is available, we download the catalog and separate objects by their orbital regimes in order to perform an orbit determination for each object, and then propagate for a long time of period. As perturbations in GEO are more simple to predict, we can extend those objects till 15 days in the case of GEO, and in the case of LEO, we propagate only for 8 days. And with that, we generate our own catalog in CCSDS standard OIM, orbit ephemeris message. And the thing with this process is that it's quite time consuming. As the amount of data is pretty big, we download 3 gigabytes every day from 18 Space Squadron. And then the computation to propagate all objects is also heavy. In total, it takes around an hour and a half to produce the GMB extended catalog that contains 30 gigabytes of data. With this updated catalog, we now can compute a conjunction analysis for our clients. In the case they upload a new operational orbit via FTP, and we download and process in order to use the Focus program close-up to generate a conjunction report and a CDM in the case of high-risk encounters. And both products are sent via email. This report is produced anytime an operator updates any orbit of their constellation or whenever the catalog is updated. Conjunction analysis is performed always against the last update of the catalog. In addition, whenever an update of the catalog is made by the 18 Space Squadron, we also make a comparison plot between the operational orbit and the catalog that is also sent via email. Thanks to the fact that we can use operational orbit for our clients, as I told you before, they can know the possible future encounters, taking into account all their own maneuvers and their flight plan.
Yes, and this is one example of how one of our conjunction reports looks like. In this case, we have used the catalog orbit of the ISS, the International Space Station. And the computation was performed last week. So in a normal day in the ISS, we have here around 7 encounters, one of them with relatively high probability of collision with the Chaser Prometheus 29. Other conjunctions with Flock constellation, which is an active constellation, and in addition, there are other possible impacts with debris from Cosmos 2251. So in this case, in general, the probabilities of collisions are not very high, but if this is the normal thing, then in the long term, there will be, of course, days with very dangerous events taking place. And actually, in the case of the ISS, they perform some maneuvers yearly to avoid some potential collisions. So it's a usual thing. And now we will give some numbers and speak about some statistics about the service. So we are currently screening conjunctions for 13 active operators with 75 satellites, more or less, mainly in GEO, but also in LEO. And in order to get an idea of the number of conjunctions that we are detecting, so we monitor around 35,000 events per year, and 5,000 of them are cataloged as high risk. So just try to think about how many encounters happen every day in space, because we are only monitoring 75 satellites, and we are getting these numbers. So monitoring all space is a really big problem with a lot of data.
Yeah, and another features that Focusoc has is that not only give a conjunction assessment service, we also compare operational orbits with the ephemeris of the catalog. This can provide us with a lot of useful information, and it is always good to check the quality of the data, of course, especially when we are using that for conjunction assessment. But in the case that a satellite has not maneuvered in a time, the thing to expect is that both orbits with more or less precisions are quite similar. For instance, in this example, there is a small difference, but it is normal for a geosatellite as it is the case. However, with time, sensors and stations can accumulate certain bias in their measures, creating situations like this one. With this information, we can correct the bias and recalibrate certain stations or sensors. In normal cases, with this information about the difference between the operational orbit and the catalog, one can assess also the importance of a received CDM, as happened before, because it was computed based on the catalog orbit and not on the operational one. Sometimes we also perform analysis with catalog orbits as targets in order to compare the results of conjunction assessment when using one or the other.
Yeah, and here there's another example of comparison between operational and catalog orbits, but of course it seems different than the previous ones, because in this case, operational ephemeris include maneuvers. It's pretty clear that the result of the conjunction assessment will be different if we use orbits including the maneuvers, and that's actually one of the main advantages of Focusoc service, actually. So normally, CDMs are generated by the 18th Space Squadron from 2 catalog orbits, and none of them includes the maneuvers. However, including the maneuvers, you can detect events before, and you can also discard false alarms because you are considering the real orbit in the long term. So this is a very powerful feature of the service when we analyze conjunctions between an active object and a piece of debris, because the debris orbit, of course, is not maneuvering. Then we have the real information for both target and chaser. But when analyzing a conjunction between 2 active objects from different operators, normally we have to rely on the catalog information for the chaser. And this is one aspect in which we would like to get better in order to perform good analysis with real information between active objects. Cooperation among the space community actually is a key factor for that. And we think that we have to follow this path. I mean, in order to face this problem, we need transparency with the data and global cooperation. So in next developments of our system, we would like to improve our standard catalog with more source data, improve the accuracy and the number of objects. But we also want to act like kind of a node for operators so that they can operate safely and get early conjunction assessment with real information, but always, of course, respecting confidential aspects. But to conclude the presentation, we think that there is a new path to follow when facing the space debris problem. And it's based on collaboration and transparency as guidance values. And Focusoc wants to be one of the pioneers of this new path. So finally, I would like to say thank you very much for your attention. And if you have any questions, don't hesitate and go on.
Thank you, Miguel and Andres. Well, now we go straight to the round of questions. We have several questions from the attendants. The first one is from Paul. Paul asked about your opinion of those satellites in low Earth orbits that are not able to maneuver. Do you think they will be a future problem?
Yeah, well, if I can start. It is clear.
Go ahead, please.
Yeah, it is clear that LEO is quite crowded with satellites and debris. And in the case that we are surrounded by active objects, we could trust that they are going to touch us. But if in the case another inactive satellite was on our path, we could do nothing. And it is true that these satellites without control used to be quite small, CubeSats and things like that. But the probability of collision may be small, but never zero, I think.
Yeah, pretty much.
Okay. We have another question from Lara. What should you do in case 2 active objects have a dangerous conjunction?
So in this case, I think we are going back to what we said about collaboration and cooperation between operators. So if a risky conjunction is detected between two objects, two active objects, probably two operators should get in contact and collaborate and study the situation and see what's the best way to proceed. But yeah, I think that's the best way that's the best path to follow. I mean, the cooperation between operators. So Andres, do you have something to add?
Yeah, maybe nowadays with cooperation we have the problem solved, but maybe if the population of these orbits continue to grow, it will be a moment to speak about another topic that may be the space traffic management. Well, first airplanes had no air traffic management, and then nowadays we cannot think in a world without it. Maybe we are seeing the same problem for the future space sector.
Yeah.
Okay. The next two questions are from Thomas. He said, the SP catalog served by the 18th Space Control Squadron spans 1 week, but Focusoc use a catalog of 2 weeks. Do you propagate from day 1 all the way to day 14 or from day 8 to day 14?
Yeah, so that's a good question. We don't actually take just one state vector from the orbit of the 18th Space Squadron. What we do is to perform an orbit determination to fit all the data, and then we take this orbit with a model that we have fit into all this data, and then we propagate that. So it's not that we are propagating from the beginning or the end of the orbit, but we are taking into account all the orbits, fitting that, and then propagating that.
Yeah, recomputing all the parameters of the satellites when doing the orbit determination.
That's it.
So it could be the more accurate that we have with this information.
Actually, we studied the residuals that we obtain with the orbit determination because it is important to know if there's a consistency between the 18th Space Squadron data and our model. And they were very, very good results. I mean, there was in geo, it was like several meters as much. So this is a good fit, actually.
Okay. Thomas asked to when there is a CA between two operational satellites, both of them belong to Focusoc users, do you compare SP catalog entries only or operators uploaded ephemeris?
In our case now, for the current moment, we use the SPCAT to perform the conjunction assessment for one with the operational versus SP, and then to the other operational versus SP. And we would like to be able to share the information between them to compute those assessment of the conjunction.
Yeah, actually, we have the technical capabilities to do that. For us, it's actually pretty much the same because we have the data. Is just select one or the other. The thing here is that both operators, they have to agree to share the information, and then there will be no problem. I mean, for us, this is a better way to operate. So for us, that's the best option. But we need this agreement because, of course.
Okay. I'm sorry, Andres, are you going to say something else? No?
No.
No, okay. We have another question from Ibnu about long-term geosatellite collocation, let's say 15 years. Is this the best product for it, or is GMB has another product to support such operation?
So I think that for that, maybe we have other tools. For collocation in GEO, there are tools dedicated to that for collocation between satellites of the same operator, colloc inside our flight dynamics solution. And I think that we have also other tools for very long-term simulations. I think that, yeah, maybe Focusoc is not the best option for this kind of study because this service is more to assess conjunctions in a daily basis with 2 weeks in the future. But for this kind of analysis, there are other tools that maybe fit better. I don't know if do you know any other one, Andres, or
no?
Okay.
Okay. Enrique asked about plans to expand the catalog. Are there any plans about this? Is it?
We are
Yeah.
studying different things, but for the time being, we have no real plan of which ones will be better, or if we can count with the Bimpel catalog, for example. But we are studying all the possible aspects for the new version of Focusoc.
Yeah, actually, one thing that I mean, we would like to do that because for me it's a very interesting thing to do, is to really perform a very, I mean, a study of the data in the Bimpel catalog, for instance, or any other catalog. Compare those orbits with the SP catalog, check the accuracy of the different sources, and then maybe use also this data for conjunction assessment. We also, the SP catalog is also going to grow, so we are also planning to include this new object. So this is also a plan to increase our catalog. But yeah, we would really like to have more sources of data and to perform cross checks, because for me this is a very interesting thing to do.
Okay, and Mohamed asked if the service also include proposal of maneuver avoid scenarios.
Well, go ahead, Andres. I think that you were going to.
Oh, well, we will start to study a bit about these kind of reports with some suggestions about avoidance maneuvers, but we are still developing all the tools and things we need in order to perform those computations. Yeah. So.
Yeah. In fact, we were integrating these new functionalities into our tools for the system. Andres worked a lot on that actually, and yeah, so we have some functionalities that are pretty interesting about this maneuvering, this collision avoidance maneuver estimation. For instance, we can perform parametrical analysis depending on the delta V and the epoch of the maneuver, so that the operator is able to select a maneuver. And we are planning to introduce this kind of information into the system, but we are still deciding how to do it. But yeah, we've been working on that, and it's one of our plans.
Okay, we have another questions related to plans about expanding the catalog. There is any plan to incorporate other data source, particularly from commercial providers?
Well, it's very related to the previous question, right?
Yeah.
Our position is that for us, more data is always good. If it provides valuable information, it's great. And maybe the difference is the thing about the commercial providers. Well, we're not using that for regularly in the system, but we sometimes process these measurements from commercial providers to perform orbit determination, and then adjust the biases of the stations of different operators to check accuracy of data. So we are able to do that, and we do that not in a regular basis for our catalogs, but yeah, it's one thing that we can do. And if we find a way to introduce that into the system so that it can get better, this is a very good thing.
Okay. In Focus Service, can you provide a statistical summary report of CDMs to operators? For instance, monthly or annual?
About the numbers of CDMs, I don't know how many we produce. There are lots.
Oh, we produce a lot.
Yeah.
Yeah, but we can generate statistics. Actually, there was one request about that, I recall, and I mean, the idea is that we were going to do that, and if this is a useful thing, so once it's done, then we can include that in the system. So I don't see a reason not to do it. So yeah, and actually it's a very interesting thing, because you can then analyze the data better and get more information from the CDMs that we are providing. So yeah.
That would be a nice.
Yes.
Yeah, we have the data, we have to process that.
Okay, and few more questions. The last ones from Emmanuel. Do you think that in the future we could envisage not only monitoring but also sort of centralized control of the objects in high congestion risk?
This will be in the line of the space traffic management, I think. Like to have a node of operational center, like it kind of coordinate all the operation between them. But for the time being, at least in Focusoc, it's not the purpose.
Yeah, it's a very, let's say, ambitious thing. It's but it's interesting. I mean, this is, as Andrés said, this is very in line with the idea of space traffic management, right? So I think that in the next years we are going to go in that direction. So maybe we'll see something like that. Who knows?
Yeah, maybe for Europe or like some coordinate.
Yeah, maybe in a smaller scale, we are trying to do something like that, because we are trying to be this kind of node between operators. So it's not the same, but yeah.
Okay, the last quick question. Do you see an optimistic future with machine learning or artificial intelligence for this file?
I think that big data for this kind of problem, in which we have to process a lot of data from a lot of different sources, we have to compare, filter, and say which one would be the good one. I think is a field that machine learning and artificial intelligence enter perfectly. Then in the assessment of the conjunction, I'm not sure. But then again, when computing suggestions for optimal collisions and coordination between different operators.
Yeah, and actually there in GMB, we have some developments using this kind of algorithms and artificial intelligence related with conjunction analysis. I'm not very involved in this project and this development, but it's called Autoca, I think, and for me it's a very interesting project. So yeah, I think that this kind of algorithms and tools could be very powerful inside this conjunction analysis problem. I don't really know how to apply them in detail, but yeah, for sure it can be very useful inside this problem.
Okay, great. We have more questions, but unfortunately we have reached the closing time of the webinar. For those questions that we haven't been able to answer, we will reach you by email.
Yes,
and also remember that if you have more questions or if you want further information, you can reach us as shown on your screen, Andrés and Miguel, and also at marketing@gmb.com. We will start this session on our YouTube channel in a few days, so stay tuned. And finally, I want to thank our colleague Andrés and Miguel, and also all of you for taking time out of being here today. We hope you enjoy our webinar, and we look forward to seeing you on the next GMB webinar. Thank you.